Just an overview of my presentation this afternoon. We look at the system, and that I mean the transmission and distribution system as it was in 2004, some of the storm impact, planning and preparation, restoration and recovery, and specifically some lessons learned from that experience and some of the things that we're doing, and questions thereafter. Okay, our system back in 2004, we basically had a distribution system at 11 kV, all radial systems emanating from Queen's Park, where we have our main generation station, the only generation station in Grenada actually. Planned capacity back then of 39 megawatts, peak demand of about 25.3 megawatts. Two generation sites, well, the one at SGU is basically a standby for the university there, which we can incorporate into our system as well. Poles devices, basically what you find in a typical distribution network, reclosers, voltage regulators, capacitors, section switches, pole mount, as well as pad mount transformers, A-brick switches. Typical length of our HV line at that particular time, 218 miles of electrical lines, primarily overhead lines. 34,000 customers, 222 employees thereabouts, right? 2004, very hectic season as far as hurricane is concerned, and for our purposes and this presentation, we look at Hurricane Ivan, which was formed in 2004, September, and you see that blue line there, and Grenada is right there, all right? Some of the storm impact, and this should be a familiar picture. You saw that in engineer Tony Gibbs' presentation, and he had something to say about that. I wouldn't get into that, but when you look at the overall impact as far as hurricane damage is concerned, especially at the magnitude of Hurricane Ivan, and it was said that it was a near Category 4 or very strong Category 3 hurricane. Storm impact as far as the lines are concerned, our distribution network, poles devices, meters, conductors, the third-party homes and so on as well, and some of those impacts. This is a picture of downtown St. George's. Again, some of the damages with regards to poles. Have some transformers on the ground there completely destroyed. Houses as well as some poles there with lines dislodged from poles as well. Storm impact, again, I just want to draw your attention to some cross arms on poles, and those particular structures did not perform very well as far as the storm is concerned and reliability of our system. And I'll say a little bit more about that as we go on in the presentation. All right, storm impact, the overhead electric distribution systems can expect very heavy damage from a storm of Hurricane Ivan's severity. Lost about 3,000 poles, 2,340 cross arms, 198 pole mount transformers, 102 miles of conductors, cost estimating just over 20.5 million EC dollars, about US 7.5 million. And that's just our system. It doesn't include cost as far as other infrastructure. Okay, there was very little damage as far as our generation is concerned. That remained intact. The effect of loss on the electrical service, you know the impact on safety in terms of our utility services, other utilities as well, telecoms and other providers that use our poles, the water supply, wastewater, and there's quite a bit of discussion on that in our earlier sessions as well. Cell phone networks, those are affected when you have loss of electricity as well. Health issues as far as hospitals and emergencies concerned, medical support, etc. I can mention, I probably take the opportunity to mention here now, as far as the hospital emergency is concerned, if they have standby generators and those are not maintained, there's a lot of pressure that could come to the utility in terms of restoring power to your main hospital as well. Right? And other medical support persons on life support machines who have that dependence on power, that reliable power. Energy availability, reliability, as far as planning and preparation is concerned, it is key. In any large-scale natural or man-made disaster, energy is the common denominator. Its loss is capable of causing severe economic dislocation. And before Ivan, the economy of Grenada was projected to grow by 4.7%. Instead, it contracted by nearly 3% in 2004. Right? So it is essential, as far as the recovery goes as well, to get your system back up and running to support economic development. And if you can prevent it from going down, that really is the key. Prior planning and preparedness, and a lot of preparedness was talked about in our earlier presentation, are key to minimizing damage and having a successful response. Construction, you'll see, we'll talk a little bit about construction design considerations for improved performance. And if you can afford it, I mean, underground, taking your overhead system underground, will spare you a lot of the stresses and even economic hardships that you would have to bear as a utility as well. Systematic preventative maintenance is going to help you as well in terms of maintaining high reliability while controlling cost. Equipment and material, if you operate an overhead system, you would need to have adequate stock because most of your materials, in fact, all of your materials are imported from overseas, and there are long lead times as well. Storm tracking, some of that was talked about this morning. As a utility, you should be engaged in storm tracking as well to give you to be able to predict some severity in terms of how you might be affected and to have a kind of predictive response as well. Communication is key. You cannot have too much communication, especially in your planning and for your backup systems as well. I can tell you it is almost impossible to do any restoration without communication, especially radio communications in the field. Repair crews, especially if you have the type of damage that we experienced during Hurricane Ivan, and you have to get overseas assistance, and you would have some logistic issues to manage. Very crucial. And there was a presentation earlier about logistics, but hopefully we can get into a little bit of that a little later in the presentation as well. National disaster management effort, as far as the country is concerned, as far as even the region is concerned as well, that is a key and an important factor in terms of your national disaster management and also any type of response that you would have as well. And it requires some regular meetings during the year and not just a couple months or a month before the hurricane season. Establish and maintain MOUs, and those would be critical as well. The last thing you want is to make significant effort to get materials in after you'd have had the type of impact that we would have had, only to find out that it comes in on a Friday afternoon and the port is closed and they tell you have to wait until Monday. All right, so those MOUs would be crucial as well, as with other entities as well, for instance, the police, to give your utility workers access to get to and from work as well. All right, construction design considerations, and I did promise to get back to that. This is what we call in our industry an armless construction, no cross arms at the top. And where you see, if you can see this clearly, you have that. Most of those were actually damaged during the passage of Hurricane Ivan. For us, we would have started introducing this, not necessarily for resilience to storms, but because of our hotline practices for reliability. We do quite a bit of hotline work on our 11 kV distribution system for reliability purposes as well. So we actually introduced these primarily to improve our safety, as well as to be able to improve in terms of our maintenance as well with that type of overhead construction. Okay. So this proved more resilience to this type of structure here during the hurricane. And this one as well. This pole went through Hurricane Ivan, and even up to today, we have not replumbed this pole as yet, but it survived. Okay. Systematic prevention, preventative maintenance, and maintaining high reliability while controlling costs. Transmission and distribution. Long-term preventative maintenance strategy based on outage risk and customer impact. And how do we achieve that? We achieve that through, detailed patrol of the T&D system, and we now have a 3-year cycle. We moved that from a 5-year cycle to a 3-year cycle where we go through the entire system and detailed defects and outline those. But we do maintain an annual visual inspections and selective maintenance as well. Annual visual inspections, pretty much a drive-through, visually checking your system. The efficiencies found are scheduled and maintained, poles, guys, etc. Repairs of deficiencies made are documented and maintained in a database, and installation of storm guides on critical structures, we ramp that up as well. Right? Enforce our joint pole construction standards with third parties. By joint poles, I mean our telecommunications and cable people who use our poles as well. We have certain standards, and we are paying more attention to that as well, because you can have them attached without having appropriate guys. And what we've noticed in Ivan as well, at the point of those third-party attachments, we had a lot of our poles breaking at that particular point. So that's something we started paying more attention to. Reliability-based trimming, and this is a part of our vegetation management. Work is planned based on risk and importance of specific lines. The higher importance the line is the higher. Essentially, we give that line more attention. Worst performing circuits and laterals incorporated into scheduling criteria. Proactive and preventive schedules rather than reactive maintenance. That is important if we are going to build a network that is more resilient to the effects of storms. And prescriptive work, selective in advance of tree trimming, crew assignments as well. So, in essence, effective maintenance, preventive maintenance is key to making a resilient overhead system. Strategic plan built specifically for vegetation management program addressing both long-term and short-term goals. If you have trees that is going to fall down on your lines, you have a serious problem as well. Not just for major storms, but for even smaller storms as well, you'll have a reliability issue. Okay. Workload data for budget forecasting, allocation of crew resources. Once you have identified all these work that you have to do, you need to schedule them, you need to get them done essentially so that you have a resilient system. Appropriate maintenance cycles based on tree growth. That's again to do with our our vegetation management, and in Grenada we have a lot of those issues as far as vegetation management. We have a number of circuits that goes through rainforest areas as well. So that's a particular area of concern for us. Clearance guidelines when you're doing clearing of traces. You need to set those guidelines for our contractors as well. And tree removal criteria established as well. Okay. Proper pruning techniques implemented. This again, as I said, that is a bit difficult. It requires a lot of supervision because we're using contractors as well, and that could be an issue if you don't manage that effectively. As far as systematic preventative maintenance goes, this is an area that we were not paying too much attention to as far as repairs to pole mount transformers. That proved very, very essential for us during the Hurricane Ivan as well. When you have damage sustained to transformers, you're not going to get them from overseas quickly, and therefore to sustain a good maintenance and repair regime for transformers throughout the year is important. It's going to help you as well in terms of your recovery should you need to do that. But apart from that, it's going to reduce some of your costs for transformers as well. Okay, so that's an area that we started paying more attention to. Equipment and materials. You need to have some system in place for storage of critical stock, and even beefing those up just in time for the season as well. As I said, the long lead times to get materials could hamper your efforts. Establish and maintain good relations with suppliers and other utilities. Fortunately for us, the utilities have had the Caribbean Association of Electric Utilities, and that has been in place for quite a number of years now, where we meet on an annual basis and to look at measures for improving our disaster management and response as well, because we recognize a very long time ago that no utility, if you have the type of damage that we've experienced in Hurricane Ivan, then you can't do it alone. Right? And that has worked pretty well for us, and we continue to support and encourage utilities to support that. Maintain your equipment and have high availability. I mean, it's not just for hurricane, but it's for your reliability as well. Active preparation, participation in CARELEC disaster management meetings and activities, and as I indicated, that have worked well for us. Actions immediately before the storm. You know the storm is approaching, then you need to activate your emergency operating center. And that should be aligned to your national effort as well. Okay, so that's an important area for us. Utility operations personnel were dispatched with trucks for us. When you consider our landmass, you can't necessarily move people into an area that is safe, so to speak. So what we do not keep our trucks in one location. We basically disperse them across the island so that persons can respond, but not in areas where you have prone to floods and so on. Okay, equip and access and plan for restoration as soon as the storm passes. Mobile communication equipment, the backup ones as well. We have some mobile ones. In Ivan, we were able to set those up immediately after the storm passes so that we can have some communication as far as the restoration effort. And hard copy of GIS maps. This proved crucial, especially for overseas crews who do not know anything about your system, where poles, what type of installations were there. Those prove very, very crucial. All right. You must have priorities in terms of your restoration plan. After you go through an event like Ivan, you must know what your priorities are, and everybody working to that. Caution, though, is that you may have crews who might have the tendency to go away from that plan because they have friends and they want to restore them, and so on. So you have to manage that situation. Otherwise, you can have a really big problem on your hands. The damage assessment, again, that is crucial, and the coordination of recovery activities and resources. Just a little example. This line was completely down. This goes to the General Hospital, and it was rebuilt basically within 2 days. And the story to this, moments before the generator at the General Hospital failed, we were able to put them on supply. Moments, right? So this line here, approximately 1.2 miles, completely rebuilt in 2 days. All right? That's when you know what your priorities are, okay? And be prepared, if you have small generators, to be able to do distributed generation at various points where your loads are and critical loads are. That is all right? Damage assessment, that is crucial. And I'll just show you, this is just a simple form that we use, developed by Carolec as well, so that we can do quick damage assessment, right? If you have the opportunity to do some aerial assessment, the GIS maps would be crucial. The type of damage that was sustained in Ivan, you couldn't recognize anything on the ground, literally. So if you can follow your GIS maps, you'll be able to know where your circuits were if you're doing an overhead or aerial assessment. All right? Just some information on the GIS maps. Damage assessment, the coordination and recovery, just to reiterate, it must be a national effort. All right? And I just want to staging overseas crews, when you had the type of numbers that we have, you've got to give that some consideration. The logistics in that, you have to have persons dedicated to that. And when you bring in overseas crews, safety would be an issue, that you need somebody to coordinate safety. All right, just some crews, persons who would have assisted. Trinidad and Tobago sent a number of crews over to Grenada, as well as Jamaica and some of the other countries that are listed here. Those are some of the issues that are associated with staging the recovery effort as well. Communications, as I said, it's key. You must have a plan to deal with communication. And communication as well, as far as when are you going to restore power in the various areas, because you can get a lot of calls to manage. And these we're able to print and put in the newspapers and on television, so that persons can get a sense as to when power would be restored to their various areas as well. So you cannot over-communicate this. That just shows how quickly we were able to restore. I mean, the event took place on September 7th, and we were up to 82%. Just about by the end of January, as far as our network was concerned. Use of generators, critical, and just some lessons learned. Remember this structure that I mentioned here after the hurricane? We basically were in the planning stages of implementing our transmission network, went back to the drawing board as far as the structural designs of these networks were concerned. And it actually proved that these will perform better as far as hurricanes are concerned. And we settled at about 120 miles per hour max wind, just in the Category 3 area. All right, so we looked at foundations and so on as far as design is concerned. Develop the company's GIS, that was a crucial thing for us, and to look at other risks, other hazards, floods, landslides, coastal erosions, and so on. These are still in the making, right? Customer location identification, technology can help in this as far as outage management and other systems goes. You can help get assistance with that. And having a complete mapping of your system as well. More stringent pole sharing agreement. Above ground electric distribution systems, again, can expect heavy damage during the type of hurricanes as Ivan's severity. An option for that is to go underground if your board will approve the cost of such installations. All right, so I want to thank you. Sorry for rushing the presentation, but I want to thank you.